When you integrate generative artificial intelligence into enterprise systems, you are not simply connecting to a model. You are exposing a reasoning engine through an interface. That interface becomes one of the most critical security boundaries in your architecture. Generative artificial intelligence systems are typically consumed through application programming interfaces. These interfaces connect applications, workflows, autonomous agents, and enterprise platforms to large language models. They form the bridge between user input and model output. If this bridge is not secured properly, every downstream layer becomes vulnerable. In this session, you will examine how to architect secure integrations for generative artificial intelligence systems. You will focus on architectural controls, not configuration steps. You will think like a security architect, not an implementer. When your enterprise integrates generative artificial intelligence into business workflows, you create a new exposure surface. A customer service chatbot powered by a large language model receives natural language input from users. A financial analysis assistant processes internal financial records and generates insights. A procurement automation tool uses an artificial intelligence model to evaluate supplier proposals. Each of these systems interacts with a model through an application programming interface. This interface handles user input, system prompts, context retrieval, authentication tokens, output responses. It becomes the control point for security enforcement. If this layer is weak, prompt injection attacks can bypass safeguards. Model extraction attempts can go undetected. Sensitive information can leak through poorly filtered responses. Therefore, securing generative artificial intelligence application programming interfaces is not optional. It is foundational. An application programming interface gateway acts as a centralized control point between clients and backend services. In the context of generative artificial intelligence, it becomes a protective layer between users and the model. You must treat the model as a sensitive backend service. Direct access should never be permitted without mediation. An application programming interface gateway provides authentication enforcement, authorization validation, rate limiting controls, logging and telemetry, threat detection. By routing all model interactions through a gateway, you gain visibility and policy enforcement capability. Imagine a scenario where users attempt to overwhelm a model with repeated queries to approximate its internal behavior. Without a gateway, this activity may go unnoticed. With a gateway, you can enforce rate limits and detect abnormal usage patterns. From an architectural perspective, the gateway defines the first line of defense. Traditional applications validate input to prevent injection attacks. Generative artificial intelligence systems must validate input for a different reason. Natural language input may contain embedded instructions designed to override system directives. You must assume that user input is untrusted. Input validation in this context includes detecting patterns associated with prompt manipulation, identifying attempts to override system instructions, filtering content that violates enterprise policy, limiting context size to prevent overloading the reasoning process. Consider an internal legal assistant that retrieves policy documents. A user attempts to manipulate the system by instructing it to ignore confidentiality restrictions. If input validation does not detect this attempt, the model may process it as legitimate context. Architecturally, input validation must occur before prompts reach the model. This may involve structured prompt templates, role-based context separation, and policy enforcement mechanisms. Large language models generate outputs probabilistically. You cannot assume that every output aligns with enterprise policy. Output filtering becomes essential. Output validation mechanisms examine model responses before they are delivered to end users. These mechanisms can detect sensitive information exposure, policy violations, hallucinated content, harmful or inappropriate language. Imagine a customer-facing chatbot generating a response that inadvertently reveals internal data. Without output filtering, that information is exposed immediately. With output validation, responses can be scanned and sanitized before delivery. From a leadership perspective, output filtering is not censorship, it is risk management. You must design systems where outputs are treated as provisional until validated. Rate limiting is a traditional control that gains new importance in generative artificial intelligence systems. Repeated high-frequency queries may indicate model extraction attempts, denial of service efforts, automated probing of guardrails. By enforcing query limits per user or per token, you reduce the risk of systematic abuse. Rate limiting also protects resource availability. Generative artificial intelligence models are computationally intensive. Abuse can degrade performance for legitimate users. Architecturally, rate limiting should be implemented at the application programming interface gateway level, not within the model itself. This ensures consistent enforcement across all integrations. Every interaction with a generative artificial intelligence model must be authenticated and authorized. Identity security ensures that only approved users and systems can access the model. Token security ensures that credentials used for access are protected, rotated, and scoped appropriately. You must enforce strong authentication mechanisms, short-lived tokens, least privilege access principles, separation between user identity and system identity. Consider an autonomous workflow that uses a service identity to access a model. If that identity has excessive privileges, compromise could lead to broad exposure. Architecturally, identity and token management must be integrated with enterprise identity platforms. Artificial intelligence models should never operate in isolation from identity governance. Open Policy Agent provides a flexible mechanism for enforcing policy decisions across distributed systems. In generative artificial intelligence architectures, policy engines can evaluate who is making the request, what data they are allowed to access, which model they are permitted to use, what output constraints apply. By integrating policy evaluation into the application programming interface layer, you ensure that access decisions are consistent and auditable. For example, you may enforce policies such as finance users may access financial knowledge repositories. Human resources users may access employee policy documents. No user may retrieve classified information through conversational interfaces. Policy engines externalize decision logic, making governance transparent and manageable. You do not need to build everything from scratch. Mature tools exist to support secure architecture. Azure Application Programming Interface Management provides centralized control, authentication, rate limiting, and monitoring capabilities for enterprise-scale integrations. Kong provides a powerful gateway solution that can enforce authentication, policy, and traffic management across distributed environments. Open Policy Agent enables flexible declarative policy enforcement integrated into application workflows. Guardrails Artificial Intelligence offers mechanisms to validate and constrain model outputs, helping prevent unsafe or policy-violating responses. These tools are not the architecture, they support the architecture. Your responsibility as an architect is to define how such tools fit into the layered reference model. Let us consider an enterprise deploying a generative artificial intelligence-powered knowledge assistant. A secure integration pattern may include users authenticate through the enterprise identity platform. Requests pass through an application programming interface gateway. The gateway enforces rate limits and validates tokens. Input validation logic scans for prompt manipulation attempts. Policies evaluated through Open Policy Agent determine which knowledge repositories may be accessed. The model processes validated input. Output filtering mechanisms review responses for sensitive information exposure. Logs are stored for monitoring and audit. This pattern is repeatable. It becomes the standard for all generative artificial intelligence integrations. As a leader, you must ensure that no team directly integrates a model without gateway enforcement. All generative artificial intelligence interactions are authenticated and logged. Policy engines are used for access decisions. Output validation is mandatory for sensitive use cases. Architecture review boards evaluate compliance with integration standards. Security cannot be an afterthought added after deployment. It must be embedded in design. Generative artificial intelligence integrations expand your attack surface. Application programming interface gateways provide centralized enforcement. Input validation protects against prompt manipulation. Output filtering prevents sensitive data exposure. Rate limiting mitigates extraction and denial of service risks. Identity and token security ensure controlled access. Policy engines such as Open Policy Agent enable consistent governance. Enterprise tools such as Azure Application Programming, Interface Management, Kong, and Guardrails Artificial Intelligence support secure architecture. Security architecture must mediate every interaction between users and models. If this lecture has strengthened your understanding of secure integration design, you are progressing toward becoming a strategic artificial intelligence security architect. In the upcoming sessions, you will explore retrieval security, autonomous agent controls, and governance integration at enterprise scale. Subscribe to the channel so you do not miss the next lecture. Like this video if you believe secure integration patterns are essential for responsible generative artificial intelligence adoption, and share your perspective in the comments. Does your organization route all generative artificial intelligence traffic through controlled gateways, or are integrations happening directly? Let us build secure, scalable, and governed generative artificial intelligence architectures together.